Hi, I'm Blake. As I said earlier, there's going to be code on these slides, and it's 24 point. I'm really sorry about that, but you might want to move down front. Feel free to ask questions during the talk. Absolutely no problem with that. On the other hand, I'm going to feel free to say, I won't answer that now if it is going to take a long time. This is a talk for beginners. I don't know much about RxJava. If you were comfortable at Anise Davis's talk the other day, you'll be comfortable at this talk. Otherwise, there's a really good talk on components, and I suggest you go have a look at that. So here's an async task. Like I said, it's tiny, but I hope you all know what they look like. I hope you aren't looking at it, don't have to review this carefully. What I'd like to do here in this talk is simply take this async task, which I'm pretty sure you all are familiar with, and just use it as a foil to contrast how RxJava does things, to see how it does things better if it does. I do not recommend simply replacing the async tasks in your application with RxJava. That would be a horrible idea. This runs. It runs fine. Okay? This is an example of it running. This is a log of its output. So what's the problem? So what's the problem? You tell me. What's wrong with, oops, giving it away. What's wrong with this? I see people all the time on Stack Overflow saying, don't use async tasks, they're terrible. So I want more noise out of this room. What's wrong with this async task? I can think of 4 things. Can I make it bigger? I don't know. I don't think so. Sorry.
We don't know if it is using live after the work.
Okay, that's a classic one, right? So does it hold a pointer to the activity? What else is wrong with it? I think there are 3 more, actually 2 more, but one of them is mine. Yeah, it doesn't handle errors very well. That's not one of the one I was thinking of. That's just my bad. Anything else? Okay, well, it's hard to see, but that access to retries right there, and those 2 access to retries isn't defined in this thing at all. Retries is somewhere external. There's one thing we know about this async task. This thing runs on a different thread than that thing does. That's the whole point. All right? That's 2 different threads accessing mutable data. You can't do that. So the problem here, or one way to look at this problem, is that any class that contains multiple methods, contains methods that run on different threads, is kind of asking for trouble. Right? So in particular, these 2 methods and this method run on different threads. They're not even annotated in this case. And as I say, that's just kind of asking for trouble. The second thing is that the executor is stalled in this backoff. So once again, like, it's hard to see, but this is retrying. This code is retrying when it fails. When it fails, it is representing the delay before the backoff as a complete thread. Okay, so it's using a full-blown thread, one of Java's most heavyweight objects. Gives the the garbage collector conniption fits. Okay, it's using that to represent the fact that it would like to delay for a little bit. This is probably not a good idea. It's worse than that. Unless you did something really smart, you've delayed all async tasks. Now this isn't impossible to fix at all, but this code is using execute. It is executing this task on the default executor. The default executor is a serial executor. It does not run all of those tasks on the same thread. It runs them on various threads, but it runs them one at a time. That means you've probably stalled all of the tasks. Okay? You can fix this by using a different executor. And the last one is the one that you guys came up with, the implicit reference to the container. There's nothing that says what the container is here, but that is a call to a method that isn't defined here. And those references to retries are clearly references to something outside this particular class. And the question is, what is the life cycle of that object? Well, if this is nested in an activity, then those things are references to the activity. And this is the one that snags just about everybody. If that's not a static class, or if it's not a static class, it has an implicit reference to that container object. If that container object is an activity, there are two problems. The first is that Android can't get the activity back when it wants it. Android thinks it's done with the activity. It's a big heavyweight object. It would like to garbage collect it, and it can't because you've got a reference to it. The second problem, though, is if you actually try to use it. Here, once this activity is destroyed, you still have a reference to it. Maybe you rotated the screen, there's a new instance of the activity here. But if down here someplace you try to refer to that thing, you are using a destroyed object, and heaven knows what will happen. It's probably not good. There's one more problem with all of this, presuming that this async task is living in an activity, is that it's just plain bad design. Okay? This is a back-end operation. This is something that is at the very least part of your model, and probably not even part of your model, probably something data that your model is fetching. How this piece of work found its way into your UI, how it found its way into an activity, is just nuts. It doesn't belong there. It belongs somewhere else. And that's sort of the main problem. Okay, so I suspect that none of this is new to most of you. I think most of you know have met these problems with async tasks before, and so you're careful with them. So let's have a look at RxJava in this context. It's the latest hotness. Can we go home now? Right? So presumably our REST service provides an observable. We subscribe to it with that parse response, and we're all done, right? Of course not. So what's the problem? Well, the problem is that it is running on the UI thread, right? That this code is running on the UI thread. There is nothing intrinsically asynchronous about RxJava. It's running stuff just the way anybody else does. It's running on the thread that gets called on. So it's blocking. So it's blocking not only for the network call, it's blocking during those retries. So you can't do that. So our first problem is not a problem that we had with async tasks. It's the problem that async tasks solved. And the question is how to get this stuff off the UI thread. Rx has a solution. Otherwise, I wouldn't be standing here. The solution is schedulers. It has two methods, subscribe on and observe on. And these two methods can be used to schedule various things with various schedulers, with a couple of schedulers. So let's just try using this once. Let's just give this a shot and see what happens. The new part is this part right here. I'm saying, sure, let's try something. Let's observe this process of trying to get something from the remote and failing a couple of times and retrying. Let's observe it on the I/O scheduler. Well, that doesn't quite work. So you can see that the test still took 3 seconds to run. Even though these things are running, even though those events are taking place on some different thread. So what's going on? So one of the main reasons that I thought this would be a useful talk is that I see on Stack Overflow a lot of people misunderstanding what, or at least not being clear on what it is that subscribe on and observe on do and why they're different. So let me take a step backwards and talk about the life cycle of a subscription. This is one of my worst slides. I'm running a test here. The test doesn't do much. It uses a logging observer. The logging observer just prints out what's happening, the life cycle of the observer. Okay? Each of the observer methods just prints itself. The important thing here is this. The first thing that happens is subscribing. Then subscribe gets called. Then next gets called twice. Then onComplete gets called. And then the test completes. That is to say that the entire life cycle of this observer happens within this. Okay, so that's the first thing to remember. The second is sort of a meta thing that I want to stick in here, is that the important thing, the way that we're going to fix this, is that observables are composable. This is one of the coolest things about Rx, is that that I can take an observable and I can subscribe something to it, which is both an observer and an observable, and then you can subscribe to the new observable, and you don't know that you didn't subscribe to the original observable. Observables all look the same. So I can wrap the some observable, I can wrap it in another observable, and you can't tell the difference. So they are composable. So let's look, given those two things, let's have a look at what observe on actually does. So here's my call to subscribe. Subscribe takes my observable, or I'm sorry, my observer, it passes it into the REST observable. Actually, I thought, so it passes it into the REST observable, then calls, so this is the subscribe call. These are the onNext calls. And then there's an onCompleted call, which I didn't draw here. I thought yeah, this is a better picture, right? So this is a better illustration of what I was trying to say. The subscribe call takes, you can barely see that little diamond, but there's a little diamond that says this is a reference to this thing. It passes it to this guy. This guy then calls onNext several times. It then calls onCompleted. And then it's done. Okay, then it returns. Then the subscribe call returns. Okay, so given that, this is what observeOn does. observeOn creates a new observable and subscribes it to the network observable. So my subscribe call subscribes, once again, the same red line, the same my observer, but it subscribes it to this intermediate thing. This intermediate thing, when it gets the subscribe call, it calls subscribe to the original, to the network observable. Now, the network observable calls onNext, but it doesn't go to me. It goes to this observeOn observable. And the observeOn observable passes it to me on a different thread. So you can think of it as in here, depending on how you want to think of it, either as queuing a runnable for this thread, or maybe as this thread has a handler. In this case, it is the UI thread, so there's a handler, and it just sends it a message. Right? One way or the other, this thing is being called on the UI thread. I'm sorry, on a worker thread. My apologies. So this thing is now running on a worker thread because this thing is queuing things to run them on the worker thread. SubscribeOn does the other thing. Here, it creates this new thing, but when this thing calls subscribe, it calls subscribe on a worker thread. That means all of the calls, all of the subsequent calls, all of these calls are happening on that worker thread, right? So this call to subscribe happens on a worker thread. That means all of the calls underneath it, unless you do something tricky, are going to happen on that thread. Yeah? So how about this? So now we subscribe on the I/O scheduler. What's going to happen? Well, almost, but not quite. So it completes right away. That's exactly what we want, right? So what's happening is the new observable is calling the other thing on this new worker thread and returning immediately. Perfect. The test completes in 8 milliseconds. Then these things happen just as we hope they would on some other thread. Perfect. Unfortunately, this last response is still on that worker thread, right? And so we can't, for instance, update a view. Finally, what we really need is this observeOn, right? That gets all of this stuff onto the worker thread, but then we're going to use, I'm sorry, this is subscribe on, this is observe on, and this observe on is going to bring us back to the UI thread. Okay? So subscribe on gets everything underneath onto the worker thread, and then we use subscribe on to get it back to the UI thread. And we end up with this. Lovely, huh? It works just the way we hope. This is back on the main thread. Whoa. Oh, that's right. Yep. So all of these responses, the test completes in 7 milliseconds. Right? So it's not holding up the UI thread. Nonetheless, these things are recurring at intervals later. And they're happening on the main thread, on the UI thread. Cool, huh? Wait, what was that? What's this thing? This is the second question that sort of drove this talk. I see a lot of questions on Stack Overflow about what's the difference between RxJava and RxAndroid. The answer is pretty simple. RxJava is a big ReactiveX library. It's huge. It's quite a large thing. And it's applicable to any Java pretty much anywhere. RxAndroid is a very small library, mostly schedulers, that works for Android. You probably want them both. So let's do one more thing. Let's add a filter. Check out the filter. The filter is still running on the worker thread, right? This is I think I've got my picture wrong. Nope, this is the filter. Okay, so the filter, here's the filter. This stuff is all running on the worker thread. The filter only lets the good request through, the good response through, so these 3 timeouts, or these 2 timeouts are ignored. Only lets the good response through, and only that one is in queued for the UI. Here's an example with the filter. The order of these things now, it should be clear that the order of these things is important now, and it should be clear why. This thing is returning a new observable, and that observable is going to return 2 less things than this observable did. This is returning an observable that schedules all of the subsequent stuff on a worker thread. And this is returning an observable which, when you subscribe to it, returns whatever it sees back on the UI thread. Buy that? Sound good? Late in the day? Okay, so quick review, what's happened so far. This is 4 lines of code instead of 18. That's kind of sweet, all right? Yeah, it's kind of good. The Lambda out there, the actual business logic, how far do I have to go back? This piece. This thing is what we really want to do. That's the only code in that whole thing, in that whole async task. It's the only code that we really cared about. Okay, is we want the response, we want to parse it. That didn't change at all. That didn't change no matter what we did. During all that fooling around with RxJava, that didn't change at all. Didn't move a bit. That's kind of neat. okay? The business logic was not affected by the other things that we did, including the filtering. And finally, this is it did a pretty good job of separating things. The Lambda runs on some thread. It needs to run on the UI thread in this case, and we got it there. But it's a little piece of code, and it runs on the UI thread. The network code happens to run, we happened to schedule it on a worker thread. But it's the network code, and it's over there. So that means the code that runs on one thread and the code that runs on the other thread have nothing to do with each other. They're completely separate. They're in different files. It's great. This is pretty good. This is pretty good stuff. So let's get to our problems. So the first of the problem was unsynchronized access to shared state. As I said, Rx does a pretty good job of fixing that, right? It keeps using this, the subscribe on and the observe on. You can keep things that run on one thread separate from the things that run on the other thread without too much trouble. And that's good. Also note that the schedulers are not threads, they're schedulers. I'll say more about that in a minute. The second problem is stalling that background thread, stalling the executor. How does Rx handle that? Well, there are two possibilities here. So the first one is sort of a straight ahead, the straight ahead solution, and then I'm just going to suggest something else. So Rx has multiple schedulers. There they are. Single, trampoline, new thread, computation, and I/O. Where I put the, and the RxAndroid has a couple of others, which I'm not showing here. Right? But you could use any of these schedulers. It makes sense to understand what they're for before you use them. So the single thread in Android schedules things on the main thread, on the UI thread. There's reason to do this. It's actually smart. It actually uses messages and the handler to schedule things at particular intervals in the future. Okay? So you can use it. The single is particularly useful with delay. Right? In particular, this doesn't use a thread to represent the passage of time. Right? Remember I said earlier that that was one of the problems, is that using a heavyweight object like a thread to simply represent the fact that you're going to wait for a little bit before you hit the remote again is a really clumsy thing to do. You can use the single thread, to schedule things, for instance, ticks of animation or something like that will happen at some point in the future. And you do it very, very cheaply. All it does is queue things up on that handler, on that looper, sorry. Okay, so here's an example. Delay 3. This toast is going to, print out whatever it prints out at 3 seconds from now. Trampoline is sort of interesting. It will schedule things to be run immediately when this thing is done. So when this task completes, it'll run that. So if you want to do things, if you're trying to do something that needs to be done entirely before you do the next thing, this is the way to do it. New thread is a scheduler that creates a new thread for each request. This seems like a fairly bad idea to me unless you really know what you're doing. All right? for exactly, we just went through this at Kotlin Conf. You don't want to be creating lots and lots of threads. You can get away with it for reasonably small numbers. Even for reasonably large numbers, you can probably get away with it. But eventually, it's just, you'll run out of memory. It's bad. The computation scheduler has exactly as many threads as there are CPUs. And the reason for that is, if you're doing there's no reason to represent weighting. There's no reason in the computation thing to represent weighting. Either you can compute it or you can't. However many CPUs is how many computation tasks you can run at once, and it doesn't make any sense to schedule more than that. So there are the number of threads equal to the number of CPUs, and the rest of the things get queued until there's a thread free. And the last one is the one that I used in my example, I/O. I/O is an unbounded thread pool. It will create as many threads as it needs to service all of the outstanding requests. Once again, it does represent, it at least represents waiting for somebody else to do something as a thread. This is not necessarily the best idea. It may be the best you can get. I want to suggest something else, though. I'm not sure I did this right. This was a harebrained idea. But it looks kind of cool to me. So what I'm going to do here is, this is exponential backoff. Right? I'm going to take numbers 0 to 4, and I'm going to map them to their squares. And then for each one of them, I'm going to create an observable that connects to this, that delays for a while, then connects to the service. And I'm going to subscribe that on the schedule, on the I/O scheduler. So this is going to give me an observable of observables, which is not what I want. I just want the observables. So I flat map that. And then I filter for the success, take the first one, observe it back on the main thread, and parse the response. So it's possible, I mean, as I say, I don't know that this is right. I don't know that this is even desirable. But it's certainly different. It's certainly a different way of thinking about things that doesn't have to do with, using threads to represent time. The third problem is implicit references to the containing class. And you can't see this, but you can see there's red up there. With any luck at all, some lambdas will, in the near future, not refer to their containers. Even when that happens, though, even if that optimization does happen, it will depend on the contents of the lambda. So if the lambda refers to anything in the surrounding context, it will still have to contain the reference to that context. So it will depend on the exact code, which in my opinion is a little bit fragile. The point is that right now they all do. They all contain references to their containing context. And so they have exactly the same problem that the async task has. Right? What solutions do we have? Pretty much the same ones that we had with async tasks. Soft references, some kind of static holder class, and disposable and cancellation. The soft reference is not a solution. Don't use it. Okay? If you do work on behalf of the user, don't throw it away, right? So if you go out, if you spend, possibly their money, their connectivity money, and certainly their battery electrons, going out and fetching data, and then throw it away because it's on the end of a soft reference, that's just bad business. A view model, just like a view model is a solution for async tasks, a view model is a pretty good solution here, right? The view model is something that has a life cycle that is different than the activity. And so it doesn't go away when the activity goes away. This is good. Okay, so if you fetch the information and keep it in your view model, and then the next time an activity connects to the view model, they get to see it, that's all good. And finally, there's disposable. So, although in the rest of the slides, we paid no attention to the return here, that return is a disposable. And you can use it like this, just the way you might have canceled your async task. You can use it in your on pause or what have you to try to tell the observable to quit doing whatever, well, actually to tell the observer to quit paying attention, to cancel its subscription. And as always, that's cooperative, okay? The observer has to be willing to cancel. It has to be willing to stop. If it's sitting in some kind of, essentially what the disposable is going to do is tell the observer to stop, quit paying attention, stop doing what you're doing. If the observer won't do that, this method has no effect. You can't, with some effort, it's not too hard. It's not too hard to make cancellation work, and it's probably worth doing. And our last problem is the bad architecture. And actually, Rx just doesn't really address this. It's still a smart idea to cache data from the network, to use some kind of Rx compatible, if you're going to use Rx, to use some kind of Rx compatible backend to take your data and stick it in a database somewhere or something like that, put it in some kind of local cache, and then only show the user the local cache. So the best thing to do is to put all of this stuff behind a database or something like that. Thanks a lot. I'm Blake. Check out my book.